This video is brought to you by SMARTICON, your partner in statistical analysis and research methodology. In many analyses, the first instinct is to compute indicators such as averages, correlations, regression coefficients, and then interpret the results. But what if those summary statistics tell the wrong story? What if the structure of the data reveals something completely different once we actually look at the observations? Statistical indicators compress information. They reduce complex data sets to a few numbers that are easier to interpret and compare. But this compression can hide important patterns in the data. Outliers, subgroups, or selection mechanisms can fundamentally distort statistical relationships. That is why experienced analysts often follow a simple principle: visualize the raw data before calculating indicators or fitting models. This step is not just good practice, it can prevent several well-known statistical paradoxes. The first example is Simpson's paradox. This occurs when a relationship observed in aggregated data reverses after the data are separated into meaningful subgroups. For example, a treatment might appear less effective overall, but when we analyze the results within age groups, it actually performs better in every subgroup. The reversal occurs because the groups differ in important characteristics that influence the outcome. A simple scatter plot colored by subgroup can immediately reveal these hidden structures and prevent misleading conclusions. Understanding these subgroups is essential for any rigorous analysis of your research data. Without visualization, these critical insights remain buried beneath the surface averages. The second example is Berkson's paradox, which arises from selection bias. Two variables unrelated in the general population can appear correlated when we analyze only a selected subset of individuals. For instance, suppose smoking and a chronic disease both increase the probability of hospitalization. If we analyze only hospitalized patients, smokers may appear less likely to have the disease. Not because smoking is protective, but because selection into the sample creates a statistical artifact. Visualizing the data across different populations or selection stages can reveal these unexpected patterns. The third example is the ecological fallacy. This occurs when relationships observed at the group level are incorrectly interpreted as applying to individuals. For example, regions with higher average income might also show higher obesity rates. But within each region, individuals with higher income might actually have lower obesity risk. Without visualizing individual level observations alongside aggregated summaries, this contradiction can easily go unnoticed. It's a classic mistake that only raw data visualization can truly safeguard against. The final example is Anscombe's Quartet, one of the most famous demonstrations in statistics. This example consists of 4 datasets with identical summary statistics, the same mean, variance, correlation, and regression line. If we only examine the numerical indicators, the datasets appear identical. But when we plot the data, we see completely different patterns: a linear relationship, a curved relationship, a relationship driven by an outlier, and a dataset where a single influential point determines the regression line. This example illustrates a fundamental lesson. Identical statistics do not guarantee identical data. These paradoxes illustrate why visualization should be one of the first steps in any data analysis workflow. Plotting the raw data helps identify subgroups, outliers, selection mechanisms, and aggregation effects that statistical summaries alone cannot reveal. It reveals the true structure that statistical summaries alone simply cannot reveal. As analysts, our job is to see the whole story hidden within the data, not just the highlights. The key message is simple. Before computing indicators or fitting models, look at the data. A few well-designed plots can reveal structures that prevent misleading interpretations and improve validity. Visualizing data ensures your statistical conclusions are grounded in the actual structure of your observations. At SMARTICON, we help researchers apply rigorous statistical methods while keeping the structure of their data at the center. Because in data analysis, the first model should often be a visualization. And sometimes, the most important insight appears before the first equation is even estimated. Contact us today to learn how we can help with your research and statistical analysis needs.